We'll stay on the topic on how industries or companies can be enabled to use quantum computing. We'll have two guests who will give us insights into quantum computing as a service, cloud-based and automized quantum machine learning solutions for industrial use cases. We have two speakers for that here today with us. Dr. David Kreplin, quantum software developer at Fraunhofer IPA. Hello to you. And our second guest speaker is David Niehaus, co-founder of Anaqor. Very happy to have you both here with us today, and I'll hand over to you.
Thank you.
Well, thank you very much. There's a presentation missing.
We'll have that in a second, I'm sure. Otherwise, we're happy to have your introduction already.
All right, thank you very much. Yeah, I'm David from Fraunhofer IPA. I'm there since a couple of months, working on quantum machine learning and quantum computing. Before I did a PhD in quantum chemistry and studied simulation technology and physics. And I will present the first half of this talk on QML solutions, automated QML solution for industrial use cases. And I will present the project AutoQML. And the second part of this talk is presented by David Niehaus, which presents the Planck ecosystem, focusing on quantum computing as a service.
Yeah, well, welcome also from my side. I'm very happy to be here today. And yeah, in addition to being one of the co-founders of Anaqor, I'm also the Planck community manager, which is why I'm very happy to share this particular head today here with David.
Yeah, so first we start with the project AutoQML, and this project focuses on automated machine learning with quantum computers. And the project is motivated by a bottleneck which already exists for classical machine learning experts in the industry, which harms applications. And you can imagine if you move to the quantum space, it even gets worse with the bottleneck. So we automatize the machine learning here. And this is done by integrating quantum machine learning solutions into existing auto machine learning frameworks. Our project is funded by the BNBK, and we approach AutoQML from three different directions. First, of course, the quantum way, where we focus on hybrid solutions in the current NISQ area, but also we have a part of a team which looks into classical auto machine learning platforms and ecosystems and how they can be used and improved. And the third direction is use cases. We have a couple of use cases from the production and automotive sector, which we use to as a development-driven approach for developing new quantum solutions. The project AutoQML will be deployed via cloud access, via Planck, which will be presented in the second half. And we just recently started in the beginning of 2002 and aim to finish at the end of 2024. And to present AutoQML in one statement, AutoQML enables the application of state-of-the-art quantum machine learning algorithms for industrial use cases. So we really focus on the industrial application. And we recently hosted a new website where you can check out for new information or contacts, which is autoqml.ai. So. Yeah, our project consists of different industry partners, and we use here a use case-driven approach to develop our framework. And we're really happy that we have four really interesting industrial use cases. The upper two coming from the production sector, which is KAB with causal analysis for machine tools, and also TRUMPF with image recognition in laser cutting. And for the automotive sector, we have EIF with creation of a data-based plant model, and last Zeppelin with automatized rating of used excavators, which is basically a regression problem. The quantum research on quantum machine learning optimization is done by the Fraunhofer IAO and the Fraunhofer IPA, where I'm part of it. And we get support in the software development by USU, focusing on the AutoML framework and GFT. Okay. So before going in more detail what we plan to do with quantum computing, maybe a short overview of AutoML framework, that because it's maybe not super common knowledge. So with automated machine learning models, the idea is to automatically construct the machine learning pipeline, which is typically done by data scientists. And this involves automated data preparation and cleaning, feature set selection, and then most importantly, selection of the machine learning models, and also optimizing the hyperparameters in the various machine learning models. And this is achieved so that you in the end load your data into an AutoML ecosystem, and it will generate the machine learning pipeline more or less automatically, probably over a week or a couple of days, and then returns you a trained and selected machine learning model, which you can use then for predictions. And therefore, AutoML simplifies the development of machine learning models and helps the industry to overcome the lack of machine learning experts. So moving on to the quantum machine learning, what do we have in mind here? Well, we're targeting quantum improvements of auto machine learning. So first of all, we want to integrate quantum machine learning in existing auto machine learning frameworks. And here we focus on state-of-the-art hybrid methods on this hardware, so what's currently doable. So we're not aiming of processing massive, huge data sets. Instead, we are obtaining from our use cases smaller examples, which we then iteratively enlarge with the process in the hardware development. And we're focusing more on like harvesting the massive Hilbert spaces, which are accessible with today's quantum computing. And we've followed two approaches. First of all, we implement various quantum machine learning algorithms into existing auto machine learning frameworks. So replacing classical machine learning models by quantum machine learning models. Here we focus on quantum kernel methods, which are needed for classification, for example, with a support vector machine, but also kernel-rich regression. And here our research topics are at the moment how we can build very universal feature maps that can be applied to very different problems, and how can we calculate kernel methods also for larger data sets with a quantum computer. Furthermore, we have a look into quantum neural networks, also quantum convolutional networks for image recognition. And here a research topic is, of course, also how can we deal with the shot noise and these problems. So this is one, probably more obvious approach into how we can integrate quantum computing into AutoML frameworks. And another step is to improve the overall AutoML process. So here we aim for an optimization of the machine learning pipeline with quantum algorithms. And we have in mind a genetic algorithm, which is accelerated by quantum computing or solving QBOs. And the second part, of course, optimization of the hyperparameters, either the classical ones or the hyperparameters of quantum computing ones. Okay, so to sum up with the first half, AutoQML enables the access to quantum machine learning for quantum beginners. Since all the process is automated, you don't need to be an expert to using the quantum machine learning algorithms for first applications. And our target is to support the industry to be quantum ready when the hardware then provides a quantum advantage, so that industry can use quantum machine learning without first training a lot of people in a couple of years. So moving on to the second part of the talk, which will be how development services like AutoQML can be accessed via the Planck ecosystem. Now moving on to David.
Thank you so much, David. Yes, so I think the relevance of the AutoQML project has been very clearly understood. The question is now, why is there this cooperation with the Planck project? And I've had the big pleasure of having been here also last year. But some of you may not know what Planck stands for. And first and foremost, it's not pronounced Planck QK or Planck QK or some other version. It's Planck, as a reference to, of course, the physicist Max Planck. And it stands for Platform and Ecosystem for Quantum Assisted Artificial Intelligence, which in German, of course, is Künstliche Intelligenz. And the idea behind it was that in 2019, a very large consortium came together. I'll be going over the partners in a few moments. And the idea behind it was that not only do we need an ecosystem that really connects all the different players of the quantum value chain, but we also need a platform that enables them to access relevant services, to offer relevant services, and to make the subsequent use of the technology much easier. The initial idea was to focus only on the quantum-assisted artificial intelligence. However, when we started in 2020 and we started with our work on the use cases, we realized that we don't need a platform that only focuses on quantum-assisted artificial intelligence. We need a platform that enables the use of all quantum applications, so optimization, simulation, and machine learning. So having taken that into account, the basic structure from Planck, the research project, as well as the platform, is to really connect the different stakeholders of the quantum value chain. First and foremost, there are the users, industrial users that want to use any sort of quantum implementation in order to solve different business problems. And David has already provided some examples in his talk that the AutoQML team is working on. And those problems are usually not worked on in-house at the different users, but rather through solution partners. So either developers or consultants that help the industrial users with the respective quantum code. And they need some sort of ecosystem, some sort of platform in order to push that code to the client. At the same time, the client doesn't want to work with all the different quantum hardware providers in order to get access to the relevant hardware machine. But industrial users today expect to have that all done through one single platform. And that's why, of course, the providers is the next big stakeholder group that has to be integrated via Planck. They will be able to offer their hardware as resources both to solution partners as well as users, as well as, that's the last but not the least, important stakeholder group, that's the experts. Quantum algorithms development, understanding of it is still very much an exercise of academic virtue. And so Planck provides an exchange platform between the solution partners and academic experts to really help them get started on their new implementations. I mentioned earlier that we're a very big consortium. You see on the left-hand side, you see the different consortium partners. We're 19. And at the same time, we've gathered more than 70 associated partners that subscribe to that vision that I provided you with earlier. From the 19 consortium partners, of which our brand mother, Stone One, is one of them, we are working on more than 30 different use cases that really range across all types of industries, as well as all types of quantum applications, so optimization, simulation, and machine learning. And the basic idea on the use of Planck, and that's really the point where I want to build on David's previous part, is that right now, the problem that quantum developers face is that their individual implementations primarily resides within Jupyter notebooks or other or as some sort of code snippet that is very difficult to give to clients to help them use it. And that's the point where Planck connects both the developers as well as the customers by acting as a service platform, right? So Planck is today able, and we're actually in the beta stage for that, in the closed beta stage, and we'll hopefully be able to open that up to a public beta later in this year, to take a quantum code, quantum implementation, and to take care of the entire hosting, deployment, and invoicing aspect. Now, through this collaboration with AutoQML, there's a very exciting new aspect of the Planck ecosystem, because we have been from the get-go subscribed to an open ecosystem approach. And right now, the service platform model is only working on enabling developers to provide their code as monetizable products to industrial users. Now, with that new aspect of the AutoQML services that you can that you see here on the lower left-hand side, Planck is furthering its image as also a development platform, right? Because so these services that David described earlier, they will become available through the Planck platform. Now, developers are not only able to provide monetizable products to industrial users, but also to other developers, meaning that Planck as an ecosystem, as a marketplace, is able to offer also additional stakeholders the potential to make money of their of their expertise that, as David mentioned in his talk, is very rare. And that is really the point why our two projects are collaborating so much. We are both funded by the German government, by the Ministry for Climate and Economic Affairs. But we want to work together because it doesn't help either projects nor the entire industry that if there are 15 different platforms coming up, but rather the idea is, and we're working on also integrating with other research projects so that the individual services, so the individual ideas that are being developed within these new projects can be leveraged or can be made accessible to this vast Planck community that we have already gathered around the research project and the platform. So that is really the gist of it, why we come together. And at this point, I want to make a little announcement, a little premiere, because our research is ongoing, and we have actually just yesterday launched our new survey, in which we are particularly targeting quantum computing development experts. So if you're designing software, if you're working with quantum algorithms, if you're an academic or an industrial expert that is trying to make quantum code usable either for little toy examples, or if you're thinking about implementing it in an industrial environment, we would very much like to invite you to participate in this survey, because what we want to do is to identify necessary competencies, tools, and processes for the development of quantum computing solutions. The AutoQML team is already providing a huge addition to the Planck platform, but there are several more ideas in the pipeline. And with this survey, we would like to gather feedback not only from within the individual consortiums or within the associated partners, but rather from this whole community that is gathered here today. And the idea is that we want to continue shaping the Planck platform to not only become a service development and deployment platform, but also a place that really helps individual quantum developers to fine-tune their respective solutions, to help them in succeeding within their projects, whatever that may be, because those projects and the depth, the range of these projects, that's really something that cannot be fathomed by an individual research project. That will be something driven by this entire community. And the idea behind it is that with the tools provided by AutoQML, with the community and the platform provided by Planck, we want to enable that community. And with that, I would very much like to thank you for your attention. And we are very happy to be here, to be available for further questions. Yes.
Thank you both very much. No, I think it's a great initiative that you showed in the end, that you're trying to interact with the community. I think that's also the spirit of the event today. We want to bring together the the community working on the on quantum computing now, but also, of course, in the future, and how to derive business impact from it. And I think we also could see that in your presentation on how you're working on generating value really from the technology. And we'd like to continue on that. Thank you very much with our